In this question, we have a scientist mixing together hydrofluoric acid, HF, with rubidium hydroxide, RbOH, in solution. Our job is to figure out the net ionic equation representing this reaction. This is just like ionic equations you might have done before, but it's for an acid-base reaction. To figure out what's happening in our ionic equation, we first need to figure out what type of acid and what type of base we have. Are they weak or strong? So hydrofluoric acid, we know that that is a weak acid. That is not one of the strong acids. Rubidium hydroxide, RbOH, that is a strong base. So what type of acid-base reaction is this? We've got a weak acid and a strong base. Now we need to remember that weak means it only partially dissociates. And strong means that it fully dissociates. So now when we're writing an ionic equation, anything that's a weak acid is not going to fully dissociate. So it's going to stay in its original form. Anything that is a strong acid is going to fully dissociate into its ions. So for the ionic equation, we're going to show it as its ions. So HF, we know that's a weak acid. So that's going to stay as the original formula HF, showing it hasn't fully dissociated. Rubidium hydroxide, however, is a strong base. So that's going to split up into its ions, which are in solution. When these react together, we have rubidium fluoride formed. Our salt is going to be split up into its ions. And finally, we have water formed, which is a liquid. So that's our complete ionic equation. So to answer this part, all we need to do is split up our salt into its ions, and then we need to split up any strong acids or bases into their ions. Weak acids and bases stay as they are because they don't fully associate. Okay, our next job is to figure out which are spectator ions and which are participator ions. So a spectator ion is anything that appears in both reactants and products. So let's have a look at our options here. HF only appears in the reactants. Rb plus, that appears in the reactants and the products. OH minus only appears in the reactants. F minus only appears in the products, and H2O only appears in the products. So rubidium plus is going to be a spectator ion in this question because it appears on both sides of the equation. So rubidium plus is our spectator ion. All the other ions here are participator ions, meaning they only appear on one side of the equation. They appear in the reactants or the products, but not both. So these are all going to be participator ions. Finally, we need to figure out the correct net ionic equation. In the net ionic equation, all we need to do is cancel out spectator ions. So looking at our complete ionic equation, Rb plus was our spectator ion. So if we cancel that out, we're left with our complete ionic equation for this reaction. So we should have HF, which appears here. We should have no Rb plus, but we should have OH minus, which appears here. Then we should have in the products no Rb plus, but we should have F minus, and we should have H2O. So that makes 2 the correct net ionic equation representing this reaction. So in this skill, our first step is identifying, do we have strong or weak acids or bases? If they're strong, they're going to split up into their ions in the complete ionic equation, just as rubidium hydroxide did here. If they're weak, then we're going to write the formula the same as it is in the equation overall, in the complete ionic equation, showing that it only partially dissociates. Next, we're going to identify spectator ions, which are those that appear in both the reactants and the products, and participator ions, which only appear in either the reactants or the products. And finally, we're going to choose the correct net ionic equation by cancelling out any spectator ions so that they don't appear in our equation.